Ferrari has just dropped a bombshell from Abu Dhabi 2025 by secretly testing a key 2026 car part that could redefine the season before it even begins. The test involved a revolutionary double pushrod suspension and advanced aero components, showing Ferrari's intent to leapfrog the competition and gain an early advantage. The twist: Charles Leclerc and Lewis Hamilton were behind the wheel, pushing the car to its absolute limits while generating critical data that could influence their 2026 strategy. And the fallout? Rival teams are scrambling to understand the implications, speculating whether Ferrari's audacious move will give them a decisive edge or risk catastrophic failure. Subscribe now. You do not want to miss a single revelation, as Ferrari's 2026 project could change the entire Formula One hierarchy. The Abu Dhabi post-season testing became an unexpected spectacle when Ferrari revealed it had been running a secret program on a key component for the 2026 car. The test involved a modified mule car incorporating advanced suspension and aerodynamic innovations, signaling Ferrari's ambition to take an early lead in the next season's development war. The secrecy of the program left rival teams astonished and sparked intense speculation across the paddock about the extent of Ferrari's technological leap. Telemetry and onboard data from the tests provided engineers with unprecedented insights. Ferrari meticulously analyzed suspension travel, ride height stability, and downforce generation at various speeds. The goal was not just raw performance, but ensuring that the new components would perform consistently under real race conditions. Every millisecond of data was logged and studied, giving Ferrari a potential developmental edge before their competitors even entered pre-season testing. The role of drivers was crucial in this program. Charles Leclerc and Lewis Hamilton were tasked with pushing the mule car to its limits, simulating extreme track conditions and cornering loads. Their feedback on handling characteristics, steering response, and aerodynamic balance allowed engineers to refine the new components in real time. This hands-on approach highlighted Ferrari's commitment to maximizing performance through both technical data and driver intuition. High-speed video and sensor data from the testing revealed how the double pushrod suspension and advanced front wing interacted. Engineers observed how the suspension absorbed high-speed curb impacts, maintaining optimal tire contact and aerodynamic efficiency. The integration of these systems aimed to reduce understeer and oversteer tendencies, providing a stable and predictable car for the 2026 season. Such insights could potentially give Ferrari a significant advantage in car balance and race pace. The technical implications of these tests extend beyond just performance gains. By experimenting in Abu Dhabi under realistic heat and track conditions, Ferrari gathered environmental data critical for durability and reliability. Components were monitored for stress, wear, and potential failure points, ensuring that the innovations were not just fast but resilient. This dual focus on speed and reliability is a hallmark of championship-winning programs. The paddock's reaction was immediate and intense. Rival teams scrutinized photographs, telemetry leaks, and anecdotal reports, attempting to decipher Ferrari's strategy and potential gains. Analysts debated whether this secretive approach would pay off or whether regulatory scrutiny could pose challenges. The testing served as a wake-up call, signaling that Ferrari was willing to take calculated risks to gain a technological edge in 2026. Finally, the broader impact of Ferrari's secret testing underscores the evolving nature of Formula One development. Early innovation and aggressive experimentation can shift competitive dynamics before the season even begins. Ferrari's 2026 Mule Car program demonstrates the interplay between engineering precision, driver feedback, and strategic foresight, highlighting how far teams are willing to go to secure an advantage. The Abu Dhabi tests may very well set the tone for the next championship battle, showing that in F1, secrecy and technical audacity can redefine the future of the sport. Ferrari's secret Abu Dhabi testing program for the 2026 car provided the team with an unprecedented data set, giving engineers precise measurements on the performance of new suspension and aerodynamic components. Sensors embedded throughout the mule car collected data on ride height, suspension travel, downforce generation, and cornering loads. The telemetry revealed how each component interacted under realistic racing conditions, offering Ferrari an early technical advantage over rival teams still in pre-season development. Mechanical simulations complemented the real-world testing, allowing engineers to predict how the new parts would behave under extreme track conditions. The mule car's suspension, including the revolutionary double pushrod system, was analyzed for tire load distribution, stress points, and response to curb impacts. These simulations ensured that the components were not only fast but reliable, with durability benchmarks designed to withstand the rigors of the 2026 season. High-speed cameras captured every angle of the test runs, giving engineers visual confirmation of telemetry readings. Frame-by-frame video analysis highlighted how the front wing and suspension systems maintained optimal contact with the track surface, even during aggressive cornering. This combination of visual and sensor data allowed Ferrari to refine the aerodynamics for maximum efficiency and stability, ensuring that the car's balance would be consistent across different circuits. Driver feedback was another critical layer of data. Charles Leclerc and Lewis Hamilton provided real-time insights into the handling, steering response, and overall feel of the new components. Their input helped engineers fine-tune the car's setup, translating raw data into actionable adjustments. By combining subjective driver feedback with objective telemetry, Ferrari achieved a comprehensive understanding of how the car would perform once fully homologated for 2026. Environmental conditions were meticulously recorded throughout the test. Track temperature, wind, and humidity were monitored to assess how the new components would respond under variable conditions. Ferrari's engineers used this data to simulate race scenarios, ensuring that the 2026 components could maintain performance and reliability in both hot and cold conditions, maximizing the potential competitive edge for the season opener. The integration of telemetry, mechanical simulations, visual data, and driver input produced a complete performance profile for the mule car. Ferrari engineers could predict lap time gains, cornering stability, and tire wear implications, allowing them to iterate rapidly. This multidimensional approach demonstrates how modern F1 teams leverage technology to gain early season advantages, blending innovation with data-driven decision-making. Finally, the paddock's reaction to Ferrari's secret testing was immediate and intense. Rival teams were left analyzing leaked telemetry, high-speed footage, and rumors to gauge Ferrari's technical advantage. Analysts debated whether this early innovation would translate to a decisive 2026 edge, or if regulatory scrutiny could limit its impact. Ferrari's audacious testing underscores the evolving landscape of Formula One, where secrecy, innovation, and early data acquisition can dramatically influence the championship before the season even begins. In modern Formula One, every millisecond counts, and the integration of new components requires meticulous analysis. Ferrari's secret Abu Dhabi tests provided engineers with a wealth of telemetry data, detailing the precise interaction between the double pushrod suspension, advanced front wing, and the car's chassis. Each sensor tracked minute variations in ride height, downforce, and cornering loads, allowing the team to quantify the aerodynamic and mechanical advantages of the new design. Telemetry analysis revealed how the double pushrod system improved weight distribution across the tires, optimizing grip during high-speed cornering. Engineers could see how the suspension absorbed curb impacts while maintaining optimal contact, reducing energy loss, and allowing for smoother handling. These findings confirmed that the component provided a measurable performance gain that could influence lap times and overall race pace in 2026. Mechanical simulations were performed to complement the real-world data. Using computational fluid dynamics and structural analysis, Ferrari tested how the front wing and suspension interacted with airflow under various scenarios. The simulations revealed how subtle adjustments could alter downforce distribution and tire loading, providing a significant advantage in both high-speed straights and tight corners. These predictive models allowed Ferrari to iterate designs before full-scale implementation. High-speed video analysis corroborated the telemetry and simulation findings. Cameras captured the mule car from multiple angles, providing visual confirmation of how the new components performed under stress. Frame-by-frame examination showed the suspension maintaining stability during extreme curb hits and the front wing keeping consistent airflow over the car's critical aerodynamic surfaces. This visual validation was crucial to ensure that theoretical gains matched real-world performance. Driver feedback added another layer of technical insight. Charles Leclerc and Lewis Hamilton reported on steering feel, responsiveness, and overall balance of the car with the new components. Their qualitative input helped engineers fine-tune suspension stiffness, damping characteristics, and aero balance. This combination of quantitative data and driver perception allowed Ferrari to optimize the car holistically, ensuring that performance improvements were practical as well as measurable. The FIA-compliant testing procedures ensured that all measurements were taken under realistic race conditions. Environmental factors such as track temperature, wind speed, and humidity were carefully monitored to assess how the components would perform under varying conditions. Ferrari's engineers could predict performance stability across different tracks, guaranteeing that the advantages of the new parts were consistent and reliable for the 2026 season. Finally, the technical implications of this secret program are monumental. By combining telemetry, mechanical simulations, high-speed video, and driver feedback, Ferrari created a comprehensive understanding of how the new components enhance car performance. This multi-layered technical approach not only accelerates development, but also strategically positions Ferrari to enter the 2026 season with a potentially decisive advantage over rivals, showcasing the cutting-edge nature of modern F1 engineering.